In this example, we have a minimization problem with three structural constraints. Restrictions 1 and 2 are active. We also have the optimal solution. We want to know under which values for the coefficients of x and y does the optimal solution still hold. In order to compute the sensitivity analysis for the coefficients of x and y, we need the slopes of the iso-objective and the active constraints. Because the slope of the three lines is negative, we will omit the sign. The slope of the iso-objective is the coefficient of x divided by the coefficient of y. In other words, 20 divided by 15, which is about 1.33. The slope of the active constraint, which in this case is restriction 1, is the coefficient of x, which is 3, divided by the coefficient of y, which is 2. 3 divided by 2 is 1.5. The slope of the other active constraint, which is the restriction number 2, is coefficient of x, which is 6, divided by the coefficient of y, which is also 6. 6 divided by 6 is 1. Under the optimal solution, the slope of the iso-objective must be between the slope of the active constraints. In order, we write first 1 because it's the lowest, and then 1.5, which is the highest. As you can see, this property holds. Now let's proceed with the sensitivity analysis for the coefficient of x. Remember that if we proceed with the sensitivity analysis for C1, the coefficient of y will be assumed to be constant. In this case, the value is 15. We repeat this relationship here. The slopes of the active constraints are in order 1 and 1.5. The slope of the iso-objective is the coefficient of x divided by the coefficient of y, which is 15. From here, we can see that C1 over 15 is greater than 1, but lower than 1.5. Therefore, if we multiply everything by 15, we get that C1 is greater than 15, but lower than 22.5. Putting these two relationships together, we get that C1 must be between 15 and 22.5 in order to keep this as the optimal solution. Let's continue with the sensitivity analysis for the coefficient of y. For this case, we assume that the coefficient of x is given and is already known that the coefficient is 20. We repeat once again this relationship here. The slope of the iso-objective is the coefficient of x, which is 20, divided by the coefficient of y, which is C2. From here, we have two relationships. 20 over C2 is greater than 1, but less than 1.5. From here, we can multiply all terms by C2, and we get C2 is lower than 20, and from here, 20 is less than 1.5 C2. In the second inequality, we can divide both sides by 1.5. This gives us a result that C2 is greater than 13.33. Now let's put these two relationships together. We need to have C2 between 13.33 and 20 in order to keep this as optimal solution. And this is our answer.